Sections 6, 7 and 8 we're going to combine on this video. Really it's equations where we've got variables on both sides of the equal sign, with integers, with negatives and with fractions, just like we had in the previous section. So this time the like terms are the variables, so I want to collect those on the same side. I normally want to collect on the left hand side and I want to keep my numbers on the right hand side. So if I have 2x here, which is positive 2x, then the opposite of adding 2x is to subtract 2x. So I'm going to subtract 2x from both sides, and then I'm going to go ahead and simplify. So 2x take away 2x is 0, which is why we do this. So the x's disappear and all we get left with is positive 20. And as it's just a single term here, I'm not going to write the plus 20 anymore, I'm just going to put that it's 20. And that was because of the inverse, because these two are opposites of each other. 6x take away 2x, 4x. Now we should be familiar with this. This is our original one-step problem. Instead of timesing by 4, we're just going to divide both sides by 4. As we did the same to both sides, that's the property of equality. 20 divided by 4 is 5, that's my substitution property. And 4 over 4 is just 1, so 1x, or in other words, just x. As I was multiplying and also had division here, these are inverses, so that would be my multiplicative inverse. If we have time, we can check this back to make sure it works too. X is 5, 6 times 5 is 30, 2 times 5 is 10, plus 20, and 10 plus 20 is indeed 30, so I have the same on both sides of the equation. (3x) equals 14 minus 5x. So I want to collect all my x's on the left hand side again here. So instead of subtracting 5x, I'm going to do the opposite if I want to move it. So instead of subtracting 5x, I'm going to add 5x to both sides. And then negative 5 plus 5 is 0, so this is actually going to cancel. So I did the inverse deliberately, so I just left with just 14. If I work out this side, 3x plus 5x, that's going to be 8x. And then now we're back to our one-step problem. So instead of timesing by 8, we're going to divide by 8. This dividing by a number is a very common last step on our algebra questions, which is why we practice so many of these in that very first section, so you recognise it instantly. 8 divided by 8 is just 1, 1x. We're multiplying by 8, we're dividing by 8, so that's an example of an inverse. And then 14 over 8, we're just going to work it out. Now we get a decimal, so I want to leave this as a fraction really. I can see these both divide by 2, so 14 over 2 is 7, and 8 over 2 is supposed to say 4. That would be a slight error there. We could try substituting back if we wanted to. We might want to do 7 divided by 4 is 1.75 if we're going to substitute back. Ones with fractions are a little more difficult to check. For our third one, 3x plus 12 equals 7x. So I really want to collect my x's on the left hand side. So I'm going to take away 7x from both sides. This is a positive 7x. That's the reason why I'm subtracting 7x from both sides. And then I can go ahead and simplify. So 7x take away 7x is 0. As these are opposites, positive and negative, that means that one's an inverse. And the rule for this one, 3x take away 7x, I'm just working that out, it's negative 4x, so that would be an example of substitution. Now I got my letters on the left, but I don't have my numbers on the right, so I need to move this positive 12 to the side, so I just have to do the opposite. So instead of adding 12, I'm going to subtract 12. And that would actually be my subtraction property of equality again. I did the same to both sides, which I didn't actually list over here. When I simplify this, 0 take away 12 is negative 12, so that would be substitution. 12 take away 12 is just 0, so I just get negative 4x. That would be an example of an inverse, one positive and one negative. Last step should look familiar now, so instead of timesing by negative 4, divide both sides by negative 4, and you get negative 12 over negative 4, which we can now work out. Negative 12, two negatives is going to make a positive. 12 divided by 4 is 3. So positive 3, and two negatives will cancel here, giving me x, and this was multiplied by negative 4, this is divided by negative 4. That would be an example of an inverse, because they are opposites of each other. So specifically, this would be an example of the multiplicative inverse. I can check the answer 3 in the beginning as well. 3 times 3 is 9, plus 12 is 21, and obviously 7 times 3 is also 21. So I actually know straight away that this answer is correct that I have here, the x equals 3. So that should cover the material for 6, 7 and 8. Two-step equations where you have variables on both sides of the equal sign.